Algebra 2. Today we're looking at section 6.3 in our textbook. First learning target is on adding and subtracting radical expressions. In order to add and subtract radicals, first off you have to make sure that they are like. By like, that means they have the same index number and radicand. When they do, you can continue. You're going to add or subtract the numbers in front of the radicals, and please do not combine the radicands. So you're going to look for like radicals. If you have 2 square root of 5 minus 17 square root of 5, again, you're going to check out the index number. Index numbers here, that's a 2 and a 2. We're good there. Same radicand. And then you're going to combine numbers in front, so like 2 minus 17, very easy, negative 15. And these are like terms, so you do not add the radicands, you just drop it down. So if there are 2 of these and then negative 17 of these, there's a total of negative 15 radical 5. And that's a good way to think about it. Example 1, 3 times the square root of 5x minus 2 times the square root of 5x. Again, check out the index number. Check out the radicands. They do match, number and variable. You are combining the numbers in front, so 3 minus 2, which is 1. Of course, you do not have to write the 1. And then there's one of those terms left. So square root of 5x. Last, check to see if square root of 5 actually simplifies. Remember, you always, if you can simplify, you do so. Square root of 5 does not simplify into another radical, cannot take the square root of x, and so that's as good as it gets. On example 2, I have 6x squared times the square root of 7 plus 4x times the square root of 5. That 2 is supposed to be the power on x. I know it's super close to that. So 6x squared times the square root of 7 plus 4x times the square root of 5. Notice that the index numbers right here are the same, square root, square root. Then notice that the radicands are different. Because they're different, and because square root of 7 doesn't simplify to anything else, neither does radical 5, then you cannot put this together. So this one has no sum, no answer, not possible. And you can choose how to write that down. So no answer. Okay, example 3. You've got 12 times the cube root of xy minus 9 times the square root of 7xy. Again, I got a cube root, I got a square root, I could automatically stop. The index numbers do not match, so no answer. So always check for those little things. And that way you're not spending time doing a problem that is unsolvable. Number 4, 3x radical xy plus 4x radical xy. Indices are 2. Radicands are the same. We can combine 3x plus 4x. Those are like terms also. So 3 plus 4 is 7. So 3x plus 4x is 7x times the square root of xy. And because this doesn't simplify, that's your final answer. Alright, so often, like, these are the easiest type you'll see. So that's the game plan for the simple ones, the adding, subtracting. However, sometimes they're in disguise. Often, actually, they're in disguise. So I don't want you to get in your head that that's all you do. Make sure that you always look to see if you could simplify the radicands before finding like radicals, because often you can. Here's what I mean by that. Square root of 12 plus the square root of 75 minus the square root of 3. All the index numbers are the same. Notice the radicands are entirely different. This problem, though, is not the same as the last set of problems. Yes, the radicands are different, but this one and this one can be simplified. So you don't want to call it too early and say, well, there's no answer to this. You need to make sure that you're aware of that too. You're going to go ahead and write 12 as 4 times 3. You're going to simplify square root of 75. Find the biggest perfect square that goes into it. So that's 25, and that's times 3. And then 3 cannot be broken down any further, so it's the square root of 3. And so in this problem, these pieces I'm underlining are the pieces that you could actually take the square root of. So the square root of 4 becomes 2. Then you'll drop your square root of 3 down. You can simplify the square root of 25. The square root of 25 is just 5, so it comes outside. 3 stays underneath. Last, you drop your minus radical 3 down. And you can see after you simplify that the radicands actually are the same. And because they are the same, then this problem does have an answer. So just be careful on that top. You can go ahead and put all of them together at one time. So 2 plus 5 minus 1. 2 plus 5 is 7, minus 1 is 6. So there's 6 square roots of 3 left. Again, combine numbers in front. Please do not add or subtract the radicands. Next example, the same idea here. We're going to switch to cube roots now. I've got the cube root of 250 plus 2 times the cube root of 54 minus 1 times the cube root of 16. At first glance, they all are different. It looks like there's not an answer, but we're going to simplify these to see if it works like this past example. So we're looking for cubes, 1, 8, 27, 64, 125, and so on. We're looking for the biggest perfect cube that divides into 250, and that's going to be 125. 125 times 2 is a good factor for that. Middle term, we're going to drop our 2 down. We're going to drop our cube root down. We're going to find the biggest perfect cube that goes into 54 evenly. 1, 8, 27, and so forth. Well, 27 will work, so we're going to write 54 as 27 times 2. And again, we've done all this in the past. Last, you're going to drop down your negative 1 times the cube root of, instead of 16, we're going to use 8 times 2. Underline the pieces that you actually can simplify. Please remember to do that. The cube root of 125 is 5. 5 will come outside the radical. Don't forget your little index number, cube root of 2. You'll drop your middle term down, so plus 2. And then the cube root of 27 is 3. Where there's already a 2 out in front, please remember to multiply those together. You'll drop your index number down and your 2. Last term, minus 1. The cube root of 8 is 2. The 2 will come outside, and the cube root of 2 will stay. Alright, so let's do some simplifying here. This is going to be 5 cube roots of 2 plus 2 times 3, 6 cube roots of 3, cube roots of 2, minus 2 cube roots of 2. So all index numbers or indices are the same, which is awesome. All my radicals are the same, so I can continue. I'm going to combine my numbers in front. 5 plus 6 is 11. 11 minus 2 is 9. I have 9 of those terms left. 9 cube roots of 2. Cube root of 2 does not simplify, of course, and so this is my best answer. So again, be careful with add subtract. They're not all easy like this top. You want to always see if you can simplify before you combine with adding and subtracting. Second learning target is how to multiply binomial radical expressions. For this class, we actually have done a few of these in the previous section, but I'm going to go through this again with you just to make sure. So on the multiplying binomial, remember binomial is two terms, you're going to either use distributive property twice, or you can use the FOIL method, first, outer, inner, last, which we have used a ton of times this year. For my example 1, I have a two-term, notice the parentheses, I have 4 plus 2 radical 2 times 5 plus 4 radical 2. So because it's a binomial, I'm going to distribute or use FOIL. First would be 4 times 5, which is 20. Outside, notice this is just a number. This is a number with a radical, so you're going to do 4 times 4, and we're back to multiply mode. So remember, you can multiply anything together. 4 times 4 is 16, and when we're multiplying, if one does not have a radical, you're going to drop the radical beside it. So 16 radical 2. Next is 2 radical 2 times 5. 5 times 2 is 10. Then you'll drop your radical 2 down. Last is 2 radical 2 times 4 radical 2. Well, that's a positive 2 times a positive 4, which is obviously a positive 8. And the square root of 2 times itself is the square root of 4 technically, but the square root of 4 is just a plain old 2. Go ahead and simplify. Next, I want you to notice that the first term and the last term are just numbers. So 20 plus 16, we're going to bring down the answer right now. 20 plus 16 is 36. Also notice that the inside terms they do match. They have the same index number and they have the same radicand. So we're back to add mode right now. We're adding 16 plus 10. 16 plus 10 is 26. So there's 26 of those terms left. 26 square roots of 2. We can't add a whole number to a radical, so this is my best answer. 36 plus 26 square root of 2. Alright, so give you a head start on number 2 using the same logic. And let's make this one be a square root this time. Okay, you have a head start on me, so let's see. First would be 3 times the square root of 5. Again, this is not underneath the radical, so you're just going to do 3 times 1 is 3. Drop your radical 5 down. Second, 3 times 7 is going to be a 21. And that was easy. Third, you're going to do the negative radical 7 times radical 5, which is negative square root of, or in multiply mode, 7 times 5, which is 35. And then last is negative square root of 7 times just a 7. So that's going to be positive 7 times negative 1, which is negative 7, and then square root of 7. And then I scan my problem, and I have like 4 terms right now currently on the board. The square root of 5 will not simplify any further. 35 also is not divisible by 4 or 9 or 16, so that's good as it gets. 7 is as simplified as it gets. So you'll notice that all 4 of these terms are unlike. If they're unlike, I can't put anything together. And so this would be an acceptable answer. You may want to move maybe the number like 21 to the end of your answer, but in either case, this is still a good product. Alright, now we're on to learning target 3, which is on dividing binomial radical expressions. Meaning, and we've done some of this before too, a little bit. So when we're dividing binomial radicals, first of all, we make sure that the radical is gone off the bottom. When a denominator contains a binomial with a radical, you need to rationalize the problem by multiplying both top and bottom by the conjugate. And remember from the past, we used this when we were doing imaginary numbers and complex numbers. Multiplying by the conjugate means changing the sign in the middle. So this is how it looks. I've got example 1 as the 3 times the square root of 2 divided by 5 minus radical 2. Because on the bottom I see 2 terms, I know I've got to get rid of the square root of 2, but in doing so I have to multiply by the conjugate. You're going to change the middle sign from minus to plus. You're going to put 5 plus radical 2 on both top and bottom. That is your conjugate. Remember, you have to multiply by both the top and bottom by the same value, because when you're multiplying by a conjugate, this is nothing other than 1. Okay, to continue, you're going to notice the numerator has 1 term here and 2 terms here. So you're going to multiply by using the distributive property. 3 radical 2 times 5. 3 times 5 is 15. You'll drop that down. And then you'll drop down square root of 2. Next, 3 radical 2 times positive radical 2. Well, 3 times 1 is 3. And then the square root of 2 times itself is actually the square root of 4, but the square root of 4 simplifies to just 2. So you'll do like 3 times 2. Denominator. Notice that this one has 2 terms here and 2 terms here. So now you're using FOIL. First is 5 times 5, which is 25. Outside is 5 times radical 2. Again, notice this is not underneath the radical. Have a good eye here. So 5 times 1 is 5. We drop our radical symbol down, radical 2. So 5 radical 2. Inside is going to be negative 5 radical 2. We definitely want those to cancel, and they're going to, because we did use the different sign. And then last is negative radical 2 times positive radical 2. Negative 1 times positive 1 is negative 1. Square root of 2 times itself is just 2. Okay, make sure you keep yourself organized on these because they can get a little long sometimes. All right, let's go back to the top. Let's see, we got 15 square roots of 2, and square root of 2 is as simplified as it gets in radical mode. We got a 2 times 3, which is 6. I can't add either one of those. So the numerator is going to stay as it is. Just like that. Okay, easy enough. Let's go to the bottom. These are like radicals. I have the same index number. I have the same radicand. We're in add subtract mode right now. 5 minus 5 is 0. 0 times anything is still 0, so they cancel. I have 25 minus 1 times 2. Well, that's just negative 2. So 25 minus 2 is 23. And then I always double check the denominator. I do not see a negative number, which is good. I do not see a fraction or a decimal, which is good. I do not see an imaginary number or a radical now, so that's really good. Last thing you always do is check to see if these numbers that I'm underlining can be reduced. 15 23rds and 6 23rds are reduced fractions, and so this is a really good answer. If any of these had been able, or you could have been able to reduce those, you do need to do so to get full credit. So keep an eye out for that. Okay, let's try number 2, and then this will be the end of the notes. For the second one, we have 6 minus radical 5 divided by 2 plus radical 3. Again, I see a 2 term on the bottom, and it's a binomial. So I want to multiply by the conjugate. I want to change the sign in the middle. Whatever I multiply the bottom by, I multiply the top by. Just a fancy way of writing 1 is all this is. Remember my comment from the past, please use parentheses around binomials. That way you don't forget to FOIL. Notice that all parts of both these fractions have binomials, meaning I've got to do FOIL. 6 times 2, 12. Outside, 6 times negative 1, negative 6. Drop your square root of 3 down. Inside, negative 1 radical 5 times 2 is negative 2 radical 5. Last, negative 1 times negative 1. Ooh, that's a positive 1. And that's square root of 5 times the square root of 3. We're in multiply mode. We can multiply anything together. 5 times 3 is 15. Let's go to the denominator next. First is 4. Outside is 2 times negative 1 radical 3, which is negative 2 radical 3. Inside is 2 times radical 3, so it's a positive version of that. And last is positive 1 times negative 1, which is negative 1. Radical 3 times itself, which is radical 9. Okay, back to the top. 12 simplified. Square root of 3 cannot be simplified. Neither can this one or this one. So it looks like the numerator is already simplified, and you're just going to drop down the same exact thing. And sometimes that happens. So we got 4 terms in the numerator of this quotient answer. Let's go to the denominator now and notice again that the inside terms are like radicals. They have the same index and the same radicand. Negative 2 plus 2 is 0. It's gone. I dropped my 4 down. Minus, this says square root of 9. Square root of 9 is just 3. And 4 minus 3 is just 1. And so my final answer, I don't have to write divide by 1. I'm just going to say 12 minus 6 square root of 3 minus 2 radical 5 plus radical 15. And that is a good answer. Okay, so recap in this section, which is section 6.3. Learning target 1 is I can add and subtract radical expressions, easy ones, and the ones that are in disguise. You have to find out if they are like radicals. I can multiply binomial radical expressions using FOIL or distributive property. And lastly, I can divide binomial radical expressions, meaning when I see 2 terms on the bottom, I'm going to use the conjugate. And the whole goal is to make sure that I don't have a radical left on the bottom of my answer.